I'm going to take a look at inscribed angles. It's going to be 2 videos, so this will be part 1. I'm going to go ahead and make a tab. Make a really small one because we're actually going to make a hot dog foldable. So make a small one. So actually go ahead and fold it in half. Cut it to the line. And then the top one will give you your first tab, and then we're going to cut the rest of the page into 3. So I'm just going to turn my book around, and then I'm going to cut it in 3. So about there, a third, and then half of the little part left. And then now I have 4 tabs. Alright, when I turn the book around, pause and copy that down on the left. And then if you can't see the circles there, you can pause them. You can see them when we're actually doing the question. So let's take a look at the definition. An inscribed angle is an angle whose vertex is the V, and the dot right where they meet is on the circle. So an inscribed angle is angle's vertex is on the circle, and whose sides are chords. So remember, a chord is from one end of the circle to the other, not passing through the center. So let's take a look at an example. So I need a V is on the circle and has 2 chords. So do a point on the circle and then draw 2 chords from that point. Bam. That is an inscribed inscribed angle. So inscribed is inside the circle. Inscribed angle. So ACB, the angle ACB, is an inscribed angle, inscribed inside. It's inscribed in circle D. Alright, so the vertex is point C. It's on the circle somewhere. And then it has a chords of AC and BC. And those are chords. The arc AB, so the arc AB is called the intercepted arc. The listening check, color in the whole sentence we're writing right now. Alright, let's look at some non-examples. So remember, inscribed angle starts on the vertex. That's not an inscribed angle, that's a central angle. This is not an inscribed angle because the vertex is not on the circle. Vertex is not on the circle, it's not an inscribed angle. So remember, if it goes through the center, if the vertex is in the center, it's central angle. And there's a special relationship between the central angle and the intercepted arc, which we're going to take a look at. So here's the fact. The central angle is equal to the measure of the intercepted arc. The central angle is equal to the measure of the intercepted arc. But the inscribed angle is not equal to the measure of the intercepted arc. This is a listening check. Put a box around but. So central angle is equal to the arc, but the inscribed is not equal to the arc. However, but it is half of the intercepted arc. It is half of the measure of the intercepted arc. Alright, so go ahead and copy down those 2 tabs in case you didn't get them before, and we're going to take a look at them. So this first one says that if I have a central angle and an inscribed angle, so inscribed is on the circle, central angle is in the middle, and they both have the same beginning point, then the intercepted arc, right? The intercepted arc and the central angle are the same, so let's call that x, and that's going to be x, and then the intercepted arc is half of x. So the intercepted angle is half the central angle and half of the intercepted arc. So let's take a look at a couple of examples. And the key thing is, by the way, to trace it with your fingers all the time. Always trace it with your fingers. So my inscribed angle is 94. My central angle is going to be twice that because my inscribed angle is half my central angle. Or intercepted arc, same thing. Alright, so 94 is half what x is. So multiply both sides by 2, you're going to get x is 188. If you didn't get it, don't worry. Just kind of pay attention. I'm going to do it again. So the measure of the arc is 188, which is the same as the central angle. So let's do another example. So this time we've been given the arc measure is 192 and the inscribed is the equation. So again, make your tracing. So those are my 2 starting points. So that's my inscribed angle because it's on the circle, and that's the intercepted arc. And what is it? The intercepted arc is twice the central angle. So there are two ways of you can write it. Inscribed is half the central angle slash arc, or 2 times the inscribed angle is going to give me the central angle arc, whichever one's easier for you to think about it. So 94 times 2 will give me 188, whichever way you're going to think about it. So this 31x plus 3 times 2 will give me 192. So the inscribed is half of the central or arc, or the arc is twice as big as the inscribed, however you want to think about it. So go ahead and get in the house. That's what you're going to get. Boxes and circles. What are you going to move? You can move positive 6 to the other side. It's going to become negative 6. This is a listening check. Color in example 2. 192 minus 6, which is 186, so divide both sides by 62. X is equal to 3. And then what we're going to do actually is plug it in just to double check our work to make sure it makes sense with numbers. So once you get an equation 1, plug it in and make sure it makes sense. So plug in X is equal to 3, so 3 times 31 plus 3, which is 96. And so now remember, we're saying 96 times 2 will give me 192. 192 divided by 2 will give me 96 because I'm going the other way. So whichever way you're thinking about it. And that checks out. So that's perfect. Very important rule. Okay, so the central angle is half the inscribed. We'll finish the other examples in the next video.
You know my prayer, you know my prayer, you know my prayer, you know my thoughts, you know my heart.